Okay, now for our exponent rules part 2. Today we're going to focus more on learning how to divide like bases and working with negative exponents. Going back to our expanded form that we talked about yesterday, let's look at when we have the expanded form but we are dividing like bases. So when we write out these these quotients into our expanded form, we can see that here in the first problem we have 2 times 2 times 2 times 2 times 2 over 2 times 2. And because 2 divided by 2 is 1, these two 2's right here reduce, and these two 2's right here reduce. So ultimately we are left with 2 to the third power in the numerator. On the second one, these x's reduces, these x's reduce, these x's reduce. So ultimately we're left with x times x times x times x, which is x to the fourth power in the numerator. And in the very last one, we have 1, 2, 3, 4 sets of x's that reduce. But in this case, we are left with 6 x's being multiplied by each other, but they are in the denominator. So if they're left in the denominator, we have x to the 6th power in the denominator. But what is left here in the numerator? Notice I'm using the word reduce and not cancel. X divided by x is 1, not 0. Just like right up here, 2 divided by 2 is 1. So really there's still a 1 left in that numerator right there. So this would be 1 over x to the 6th power. Well, writing out these in expanded form can be kind of exhausting, and these exponents can get to be very big. So that's why we want to learn a rule. Can you visualize the rule? Hopefully you can see that when we divide like bases, we subtract the exponents. In this first one, we have 2 to the 5th divided by 2 squared, and we are left with 2 to the third power. The second one, 7 take away 3, we are left with 4. And then the last one, 10 take away 4, we're left with 6. But because we had more x's in the denominator, the x to the 6 goes in the denominator. And that's pretty much our dividing like bases rule. Alright, so let's go into applying that rule now. Let's look at this first example we have here. We have x to the 9th divided by x third. Because these are like bases, we can subtract these exponents. So 9 take away 3 is 6, and we are left with x to the 6th power. Write down the next two on a sheet of paper and try them. When you're finished, start back the video. Alright, so there's two ways to look at this second one. One is we can use our exponent rules. If we are dividing like bases, and these are like bases because both of the bases are -3, we can subtract the exponents. So that would give us -3, and then 4 take away 2 would be to the 2nd power. And then guys, we know that if we multiply -3 times itself, -3, that would ultimately give us +9, and our answer right here would be +9. Another way we could look at it is by going ahead and evaluating each part. If we have -3 raised to the 4th power, and again we can come over here, -3 times -3 times -3 times -3. Right here this would give us +9. These two would give us +9. And 9 times 9 would give us 81. So in the numerator we would have 81. And then -3 to the 2nd power we've already evaluated is 9. So what is 81 divided by 9? It is 9. And technically it doesn't matter which way you do it. It's just sometimes using the exponent rules when you recognize that you're dividing those like bases is going to be much quicker. And then for our last one here, we have m to the 10th divided by m to the 9th. So when we subtract those exponents, we get m to the 1st power, which is just m. Alright, notice in all of these examples, the power in the numerator was higher than the power in the denominator. So what do we do when it's not like that? There's a couple of ways you can do this. Some teachers always teach that you always do the numerator minus the denominator. But when that happens, you will half the time get a negative exponent. So the way I teach it is always subtract the smaller exponent from the larger exponent. And then the base stays where the larger exponent was located. That way you avoid having to work with the negative exponents. Alright, so let's look at an example. Looking right here, we have f squared divided by f to the 7th. So I would say 7 take away 2 is 5. And so I'd have that f to the 5th in the denominator. Of course, since there's nothing left in the numerator, put that 1 there to hold the spot of the numerator. And our answer is 1 over f to the 5th. try the next two. Okay, let's look at this one. So when we look at our y's, 4 take away 2 is y to the second power. The larger exponent was in the numerator, so the y squared goes in the numerator. 3 take away 2 is 1, and again the larger exponent was in the numerator, so that z to the first stays in the numerator. And you can put the little 1 there, but normally you're not going to see it. You're just going to see y squared z. Looking at the next one, for our m's, 5 take away 2 is 3, so we'd have m to the third power in the denominator. And then even though you don't see it there, there's a little 1 on that end. So 4 take away 1 is 3, and then that n cubed would go in the numerator. Something I've seen students do is they see the 3 in the numerator and the 3 in the denominator, and they think those reduce. That is incorrect. Those do not reduce. They are not a base. They are exponents. Folks, remember that really means n times n times n over m times m times m. There's nothing that reduces here. That is n cubed over m cubed. Okay, so let's shake it up and add a little bit more to our examples. What about when we throw some coefficients in there? Folks, y'all just have to remember that you're going to divide your coefficients like you've always divided. Like you've been dividing since you were in 3rd grade and 6th grade when you started learning negatives. Don't get coefficients confused with exponents. All these rules that we are learning are only for our exponents. So when I look at this first part right here and it has negative 10 divided by 25, I'm just reducing this. 5 goes into negative 10, negative 2 times. 5 goes into 25, 5 times. So in the front of this problem, we're going to have negative 2 in the numerator and we're going to have 5 in the denominator. Now we'll apply our exponent rules. 9 take away 7 is 2, so that will give us x squared in the denominator. And in this case, these z's right here are just going to reduce because z divided by z is 1. So our final answer is going to be negative 2 over 5x squared. All right, copy the next two on your paper, try them, and when you're done trying them, restart the video. All right, let's check this out. So negative divided by negative, we know is positive. We know that 4 goes into itself 1 times, and 4 goes into 12 3 times. So in the front of this, we are going to have 1 over 3. Then let's look at our m's. 6 take away 2 is m to the 4th power, goes in the denominator. 4 take away 3 is n to the 1st power, goes in the numerator. And if you want to write that a little bit more cleaned up, we can say that is just n over 3m to the 4th power. Of course, it would not be wrong if you left it with the 1s in there. All right, looking at the last one, negative 3 over 9, and negative divided by a positive is going to stay negative. 3 goes into itself 1 time, and 3 goes into 9 3 times. So when we go to write out our answer over here, we're going to have negative 1 in the numerator and 3 in the denominator. Okay, even though you don't see it, there's a little 1 on that p. So 3 take away 1 is 2. So that gives us p squared, and that p squared would go in the denominator. And then right here, there's a 1 on this q. So 2 take away 1 is 1. And that q to the first would go in the numerator. And again, if you want to write that a little bit cleaner, you could say that's negative q all over 3p squared. Okay, so the next part we're going to learn about our negative exponents. All right, in yesterday's lesson we looked at two patterns, then they're right here, and we to help us learn our zero our zero power rule. Anything raised to the 0 power is 1, because what we did was we looked at what was the pattern of the numbers. We went from 16 to 8 to 4 to 2, and so we realized that each time we were halving the previous term, we're dividing it by 2, so the next number was 1. What if we continued that pattern? If we continued to divide by 2, or half the previous term, half of 1 would be 1/2. Half of a half would be a fourth, and half of a fourth would be an eighth. Let's pop these numbers back into our pattern up here. So this would be 1 over 2, 1 over 4, and 1 over 8. Notice right here that when you have 2 to the first power, the answer is 2. But when you have 2 to the negative first power, or to the negative 1 power, the answer is 1 over 2. 2 squared is 4, where 2 to the negative 2 power is 1 over 4. And look right here, 2 cubed is 8, where 2 to the negative 3 is 1 over 8. Let's look at the next one if we continue that pattern. In this pattern, we could notice that we were dividing by 3 each time, or taking 1/3 of the previous term. So if we continue that pattern, a third of 1, or 1 divided by 3, is 1/3. A third of a third is 1/9, and a third of a ninth is 1/27. So let's fill these numbers back in. That's 1/3, 1/9, and 1/27. And you notice that we have the same thing going on. It's like when we raise it to a negative exponent, it does the reciprocal of that number. So, pretty much what we learn about that is anytime we raise a base to a negative power, it means reciprocal of that base and then raised to that power. And that's our negative exponent rule. Alright, so negative exponents. So if you have some base, we'll call it base A, raised to the negative n, it really means 1/a to the positive n. Or if you have 1/a to the negative n, it really just means a to the positive n. Ultimately, negative exponents just mean reciprocal of it. Now, what if you have an entire fraction raised to a negative exponent? My advice is go ahead and do the reciprocal of it first. Then change that negative exponent to the positive exponent. When you do the reciprocal of, it changes that negative to a positive. And then distribute that exponent to your bases. Okay, so let's start out basic. X raised to the -2 power. As soon as I see that negative exponent, I know I need to get rid of it. So really what that means is 1/x to the +2 power. Pretty much what happens is when you cross that line, and that line being your division bar right there, it changes its sign. So ultimately, to get rid of negative exponents, and we always want to get rid of negative exponents, we only want positive exponents in our answer. Any base that's raised to a negative exponent, you just pick that base up, you move it to the other side, and when we say the other side, that means numerator versus denominator, and when you change over to the opposite side, it becomes a positive exponent. If you can just learn that, it's super simple. All right, let's look at the next problem. So be careful. This 8 is not being raised to a negative power. Only the x is. So the 8 stays right where it belongs. And then we're going to pick up this x to the -3, move it downstairs. And when it moves downstairs, it becomes x to the +3. And we're done. Where in the last one, the entire product is being raised to the negative exponent. So we pick up that entire product, which is 8 times x, and we put it in the denominator. And when we pick it up and put it in the denominator, it then becomes to the +3 power. Then we use our power of a product rule, and we distribute that power. So that's 1/8 cubed, x cubed, and then you would evaluate 8 cubed, so that'd be 1/512 x cubed. And again, you can always just go into Desmos or your graphing calculator and type that in. All right, y'all try the next 3. All right, so the first one, 5 stays exactly where it is. X to the -4, it lives in a negative neighborhood, needs to move to a positive one, so we move her downstairs, and it becomes x to the +4. And y to the 0 right there, that's really just 1, y'all. So what I normally do is I just scratch it out, because it's like saying times 1. If you want to change it into 1, it's like saying times 1 right there. But then we'd still ultimately end up with 5/x to the 4th. So normally if I just have one little part of my problem, raise the 0 power, just kind of scratch it out. Alright, next one. Be very careful. Guys, this -4 up here in front is a coefficient. It is not a negative exponent. We can have negative numbers. We just don't want negative exponents. So that -4 stays exactly where it is. X squared stays exactly where it is. The only thing that gets moved here is that y to the -4th. It moves downstairs and becomes y to the +4th. Please do not get negative coefficients confused with negative exponents. And then here in the last one, because the whole thing's being raised to the -1 power, we pick that whole thing up and move it downstairs. -5xy. It would then become to the +1 power. And of course, anything to the first power is itself. So this is 1/-5xy. Okay, so let's start putting all these rules together. Biggest advice I could ever give you when doing these problems, guys, is follow your order of operations. There's a lot of different ways to do these problems. If we were in class, I could have each of y'all go up to the board, and y'all probably, like I have 10 of y'all, and y'all might all do something a little different and could still get the same answer. But the quickest, most efficient way is to follow your order of operations. And order of operations tells us to simplify inside our grouping symbols first. So we're going to simplify inside this parentheses and ignore that square out there. All right, so 2 over 8. Remember, these are coefficients. We're going to work with them like we always have. 2 goes into itself 1 time. 2 goes into 8 4 times. So therefore, we're going to have that 4 left in the denominator. Now we are dividing like bases, so we are going to subtract our exponents. We have p to the 4th in the numerator, excuse me. We have p to the 1st in the denominator, so that leaves us with p cubed. And then q cubed over q squared. 3 take away 2 is 1, so that's q to the 1st. All raised to the 2nd power. Now that we have simplified inside these parentheses, now we can distribute that power. So that would be p to the 6th power, q to the 2nd power, all over 4 squared. And then that's p to the 6th power, q to the 2nd power, all over 16. And this answer is perfectly fine. I love it. It's beautiful. But if this was multiple choice, you might also see it written like this. 1/16 p to the 6th q squared. Sometimes when all it is a number left in the denominator, there's no variables, they will rewrite it as a fraction and make it a coefficient. But both answers are acceptable. Okay, I would like for you to write these problems down on a sheet of paper. And once you've written them down, just pause the video so you can write them down. Try them, and then turn the video back on so we can see if you're doing them correctly. All right, so for the first one, this f to the -7 moves downstairs, becomes f to the +7. F to the 4th was already positive, so she wanted to stay right where she was. And then when we move it, we are multiplying like bases, so we add those exponents. So that becomes f to the 11, and the 1 holds the spot of the numerator. For the second one, there's a couple of different ways to do it. But ultimately, guys, you're really just multiplying like bases. So if all we're doing is multiplying like bases, we can just add those exponents. 0 plus 3 plus -2 is 1. So then that would just be n to the 1st, which is ultimately n. Or you could have worked through each part. N to the 0 is 1. Then we have n cubed. N to the -2, because it's raised to a negative exponent, needs to move downstairs, become n to the +2. And then we're dividing like bases, so we subtract those exponents. 3 take away 2 is 1. So 1 n to the 1st is just n. You can see either way you're going to get the same answer. 5 to the -3. We pick up that 5, base of 5, we move it downstairs. Remember, cross the line, change the sign. That becomes 5 to the +3. And then if you multiply 5 times 5 times 5, that is 125. So that becomes 1 over 125. If you're using a graphing calculator, you can always just type 5 and then use your little caret button, raise 2, and then you would type -3 and then press enter. And it's going to give you a decimal, but then if you come over here and you do math and go to change fraction, that first one, press enter again, it'll change it to 1 over 125. So when you're working with just numbers, you can actually check this stuff in the calculator. You can also do this in Desmos. If you wanted to use Desmos for this problem, let me pull this up real quickly. All you would do is come over here, and you can just pull up your little tablet down here, and just type it in 5, and then you just click this A raised to B, and it kind of does the raised 2, and then type in -3. And when you do it, again, it gives you a decimal over to the side. And then you'll notice over in Desmos, it has this little like fraction looking thing over to the side. Just click that and it'll change it to a fraction for you. 1 over 125. Okay, then for number 4, this is the only time I would suggest not following order of operations. The entire quotient here is being raised to the 0 power, and regardless of what's inside, anything raised to the 0 power remembers 1, so the answer is just 1. For number 5, because this whole quotient is being raised to a negative power, just do reciprocal of it. The reciprocal of 6/5 is 5/6. As soon as you do that reciprocal, that exponent goes from being negative to being positive. So it's 5/6 squared, and then just square each base. 5 squared is 25, and 6 squared is 36. And then for number 6, the last problem, remember, you're going to reduce your coefficients like you always have. 9 goes into itself 1 time, 9 goes into 27 3 times. and a negative divided by a positive is still negative. M cubed is going to stay right where it is. That m to the negative 2, I'm going to pick it up and move it upstairs. It becomes m to the positive 2. The n to the 5th reduce. And then that y to the negative 4th is not happy where it lives, so we're going to cross that line, change the sign. I find it's a lot easier if you go ahead and get rid of your negative exponents, then do your multiplying or your dividing. So then when we clean this up, m cubed times m squared is m to the 5th, y to the 4th is right where it is, and in the front it is negative 1/3. Don't worry about this negative 3 cubed over to the side. That's for another problem that we're going to look at tomorrow. Guys, tomorrow we're going to put these rules a little bit more together, but for today I want you to go into Delta Math and practice more of these dividing rules and some of the more simpler problems. All right, make sure you check back in tomorrow. We'll have a much shorter video tomorrow and an assignment. Thank you. Have a good day.